You could build a house without structural engineering, but why would you want to? Hi everyone, I'm Dan McJunkin with HoustonBuilders.com. Thanks for taking the time to watch this video. Today I'm talking about structural engineering. Now, structural engineering is the kind of the backbone to your home. Most people that are dreaming of building a home, they don't think of the actual structure and who's going to design that. In fact, most individuals assume that the builder just knows how to build the house. Well, to me, there's more to it in terms of hiring an engineer than just building the house. There is the expectation that somebody's going to be responsible for the decisions that are made on site. And if you have a builder that is making your decisions, or even worse, passing those decisions to a framer, somebody's going to get crossways. Somebody's going to take on responsibility and actually liability that they shouldn't take on. So for that reason, most banks would require they want to see your structural engineering along with your plans. It should just be a component of what they're investing in, but it's not always the case. In fact, there are cities that don't require structural engineering, and my biggest caution to anybody that's thinking about having a home built is check with your local municipality or your county. It varies across the states. I'm building in Texas, the southeast portion of Texas. I am a material estimator, and that's where this plan comes from. And by the way, I'm able to show you this plan. It is copyrighted, but this is educational and for educational purposes only. That's why I'm showing you this plan. We're not showing it to use the design elements here, but just to illustrate the need for structural engineering. So what we're looking at right now, if you are in an area that requires structural engineering, you want to allow plenty of time for the engineer to do his work. In some cases, if they don't have much on their plate, you could expect engineering to take a couple of weeks, but most often I'd allow a couple of months. And it's hard for anyone that's building a home to understand that there's a whole process that has to, especially when there are permits involved, that could take many months just to get through. Certainly if you're on the West Coast, some of those states have a lot of very rigid requirements. So plan ahead. But let's get into this. Why do we need structural engineering? Well, because right now we are looking at the vision of an architect or a building designer. That building designer or architect has done their best to take information that either a builder has given them if they're going to build a spec home, or that a custom building client has given them, and they've interpreted that information graphically. And the way I put it is the plan becomes a graphical specification for what you're going to build, but it is not the structural specification for what you're going to build. So what we're looking at is a nice floor plan. It's got several bedrooms. It has all the components you would expect, a garage, a number of bathrooms, a porch, and that kind of thing. But let's take a look at the front so you can get a sense. It is a single-story home, some very specific elements. And you'll see a lot of notations drawn on this plan. Like I said, it's a graphical specification. It's almost like a builder, if they're really doing a great job, they have a written specification or scope of work or both that they're going to sign you up with under contract to build this home. Well, let's zoom in and I'll talk about some of the graphical specification elements. And as the buyer is expecting the builder to pick up on these details, the builder is actually responsible for building according to these details unless they have some documentation as to why they're not going to, usually done ahead of time. So these are some of the architectural understandings that are being passed along through the plans to the builder, to the tradesmen that are working on this house, as well as to an inspector that is going to look at it. Now, bear in mind that inspectors are really focused on code more than they're focused on the structure. Now, the structural engineer, he's also focused on code, but he doesn't really concern himself with design because, after all, his is a profession, so is the architect. a profession, and they don't really try to do each other's work. But what I do see from time to time is a plan that will say one thing and an engineer that will say another. So I've got an illustration for you on this very plan where that has happened. Now, first let me show you some of the graphical elements that are being designed, but not by an engineer, but by the architect. That is, we see this gable here, and it's got some staggered shake shingle siding, and it's got a gable truss that's built on site. Once again, these are decorative items. They're just design items. But look at this design item. This is called a typical wall section. It's not engineered. It's just a typical wall section. This is the architect telling the builder, if I were you, I'd build it like this. It may or may not be designed according to code. This design might be required by a given municipality, especially if this has to be a firewall, like if a house is going to be right next to another house within 5 feet, typically. In some areas, it's 3 feet. But, where you have to have a firewall, and whether that's going to be like vented soffit. In this case, they are actually showing we've got some rafters drawn in, we've got ceiling joists, these squiggly lines here, that indicates insulation. And this is the ceiling for the overhang called soffit. You see the hole there. That is venting for the soffit. There's a whole system to this where the air can go through the venting and ventilate through the roof, through ridge vents. But it's not engineered. It looks pretty. It looks like a wall, but as far as engineering is concerned, it's just a picture. But here the designer is saying you're going to have some half-inch sheetrock, some batt insulation, and so forth. But once again, it's not engineered. So how can I prove it's not engineered? Well, let's start at the foundation. This designer is telling somebody that, now this is the foundation beam. Now, the beams in our area with a monolithic slab are a component of the slab. In other areas of the world, you might see this as a footer, maybe a 24-inch wide by, 12-inch deep footer with some rebar in it, with the slab then poured later on top of that. That's not how we do it in our area. This is called a monolithic slab. In this design, there are these 4 dots here. Those represent rebars. These dashed lines between them indicate stirrups. They're a cage that's going to turn these rebars into a cage, but they only show 4. I want you to key on that. And they also say that the depth of this beam is 18 inches typical tip. So, but what they don't give us is the width of this beam. So this will vary according to some things like something we call a soil test. Another technical, it's called a geotechnical engineering survey, and it is a crew that comes out with a special truck that drills what we call cylinders, or about 8-inch holes, and they grab the dirt, usually 3 of them on a job site that's a regular lot, and they take those to a lab and they see what's in that soil. Then the engineer takes that data and they draw this. And this is your foundation. So now what we've gone from is the structure. I'll go to the floor plan. Remember, that's the floor plan, but now we have the foundation. It mirrors the floor plan in a different way. Now, when we're talking about beams, we're talking about the structural concrete in our case, the foundation elements that are trying to transfer the loads that originate at the ridge beam of the house, and they transfer from the ridge through the rafters to the walls, to the foundation, to the soil. So we're trying to transfer loads to the soil without disrupting the soil or displacing it, because if that were the case, then the foundation would fail. That would be a problem. So when I'm showing you this, there are some details I'm going to show you in a moment that will help you understand what's going to go where. For the moment, let's kind of look at some areas. This is the garage area. And you'll see some notations, S5, S4, S2, S6. Each of these designations is telling the builder and his tradespeople what type of beam to put here. I'm going to show you the picture of what it looks like, but basically it's the width, the depth of the concrete. It's how many rebar or what type of structural support it's going to have. This is a rebar slab, but we also could do a cable slab. We see production builders using something called tendons, also known as a cable slab. Totally different methodology, although the design would look very similar. So all of these S designations, they relate to some details, these details. And so what we have is beam 1, this would be S1, this would be beam 2, or in our case S2. Some would say that this is structural sheet designation. I'm looking for the structural designation. So some people would look for the sheet name and then a number, like I might say S2/1. In this case, what we're looking at is what that same beam should look like. Now, I'm going to take you back real quick and remind you that they said this beam could be 18 inches with 4 rebar. But when we go forward, we see that the engineer actually says, nah, you need 6 rebar. Oh, and by the way, I want my beams to be 36 inches deep, twice as deep as what the architect said. So this is a good reason not to trust the architect to be the engineer. Architects are experts at what they do. And I guarantee you this architectural plan that I'm using as the illustration is an excellent plan. I think the architect has taken great pains to draw the plan the way the buyer expects it to be built and in a way that would satisfy both the builder and the trade. But when it comes to the structural elements, what they've said is, no, we want very specific 36-inch tall beams, and we want them to be at least 1 foot wide. And I did say at least. A lot of times, now this is something, check with your engineer, but a lot of engineers, they don't mind if that beam's an inch deeper or an inch wider. They do not want it an inch too shallow or an inch too narrow. In this case, he also wants 6 rebar. And by the way, he wants stirrups that accommodate those rebars. And he's designated that how we're going to support the main field of the foundation with number 4s. At number 4 rebar, that happens to be 1/2 inch. I look at it as 4/8 rebar, but they're called number 4 rebar. And so these will be at 18-inch spacing. And they don't really show it here, but they'll actually be supported by something called plastic chairs to keep the rebar in the center of the concrete so that it does a job. So what you're going to see here is a lot of consistency, 36 and 1 foot. We go down to this beam, 36 inches, 1 foot. In fact, each of these beams is designed to be 36 inches from the top of the slab to the bottom of the beam. Now there's some neat details and nuances here, but I think already you can see why an engineer got hired for this job. And that is because the architect didn't really have a great handle on the requirements for the structure. So that's all well and good, but already we have committed to paying a structural engineer for doing this form. And basically you could hire a foundation engineer separately from the structural engineer. Same guy, different modality. In other words, the foundation engineer, he's only focused on that. He really understands the soil tests that came back, and he really understands what he's trying to accomplish through the structure. And by the way, it could very well be one and the same person. And so this is all designed. It's not guesswork. Even though a professional builder that's built a few hundred houses would know, hey, this will work, especially for a single-story house. When we're talking about a 2-story house or a house that's not a square, maybe it's an L shape or a U shape or a bat wing type shape, the structural needs really get complicated, which is why we want to hire the professionals. Let's talk about the plan. What I'm showing you here is a fly sheet version of the roof. And I guess maybe it's not fair to start at the roof. I like to build a house from the ground up, but let's start at the roof. And I'm going to show you, we're transferring these loads from the roof all the way through the house. But what you're going to see here, it's a nice design on a roof. We call this a fly sheet view. And this is like you're flying over it, or maybe like if you were a fly, this is what you would see looking down. And it's a great schematic view of the roof, but it doesn't tell us anything about the size of the rafters, how far apart they're spaced, how we're going to support the roof, and especially things like supporting the rafters mid-span with something called purlins. It doesn't talk about how we're going to support those the ridge and the valleys and hips, because all of those are components, especially a valley is supporting rafters and the hips that are above them. So there's just a lot to go into this that, yes, an experienced builder and even an experienced framer is going to know what to do. If you're building a home in the middle of the desert, there's no city around and nobody really cares what you're building, you can take your chances. Your family's going to live under this structure, and you don't want it to have a structural failure in some way that might injure them. Okay, it's a far-fetched thing, but it could happen. And when it happens, if you're the one that made all these structural decisions, you have nobody to blame but yourself, which brings me to another issue. One reason you're hiring a structural engineer, yes, to do the right thing. The other is the city may require it. But the other thing is, who's going to be responsible if something doesn't work? If your roof sags, if your ceiling bows down, if the beams are not structurally capable of handling the loads. This is why a builder, really a professional builder, they're going to pass this right back to you as the buyer. If you want them to hire an engineer, they're going to charge you for it. So in my opinion, this is one of those things that's just a need. So now let's see how the engineer looked at this very same roof. So what you're going to see here is he's drawn in every rafter. And he's told us, if we zoom in here, he's given us a lot of notes about what we're going to build. He's saying all rafters are going to be 2x6s. Now, I think I said it before, I'm a material estimator, and I do lumber takeoff estimates. And one of the first things I look at is the engineering. Does the plan have engineering, or do we have to have some conversations so I can shed liability back to the builder, because I'm not an engineer, and he can give me his idea of how he's going to frame this. In this case, everybody's protected. We have an engineer. He is charging you a lot of money, and he has liability insurance in case the builder has to build this the way the engineer says. But if there's a failure, then it's on the engineer to make it right. And builders know it, and the engineer knows it. That's why they charge what they do. All rafters are 2x6. Ridges, hips, ridges, and valleys are going to be 2x8s minimum. And by the way, word to the wise, when you exceed 9 and 12 on roof pitch, usually you go twice as large. 2x6 rafter would then require a 2x10 hip, ridge, and valley. That's often checked by your inspector, although I do see engineers that miss this detail. So move on. You have some details here where the engineer is stating for you, the buyer, for the builder, but really for the inspector that's going to review this plan once the house is built. After the lumber's already been used, he's going to look at this plan and say, did the framer build it this way? And if he didn't, by the way, the onus is on the framer, the builder, and everybody but the engineer. Because I have literally had structural engineers have to write letters saying that, yes, it wasn't done according to my engineering, but yet telling the inspector that, yes, it will meet code. That is called an engineer's letter. It generally is accepted. Check with your municipality or county to make sure they would accept an engineer's letter. But if you don't build according to the engineering, that's what you're going to have to do. Or if the engineering was flawed in some way, maybe a job site requirement, and this does happen, where the builder gets on site, realizes something has to be framed differently, gets with the engineer. The engineer doesn't redraw the plan. He writes a letter and explains to the inspector what's going on. Usually that's accepted because an engineer has the capacity to trump code if there's a logical reason to do so. They would never do so in such a way that they took on undue liability. So that's just kind of how it works. At least in our area, your mileage may vary. So what we're looking at now is we're going to look at some details that really give the framer a little bit more help. Now, what I don't see on this plan is where the purlin supports are. What I know as an estimator is if the rafters are going to be 2x6, then our purlins need to be 10 feet inside of plate. The unsupported span usually can be no more than 10 feet. And what I'll do as an estimator, I'll just go ahead and throw in purlins for every 10 feet. If I saw these were going to be 2x8s, I might make different decisions. If you're building in an area with snow load, for example, in Minnesota, maybe your rafters are going to be called out as 2x10s. And I see this type of thing a lot, which is what I do as an estimator. I go through the plans, through the engineering, have conversations with the builder to make sure that I'm not just throwing Texas specs at Minnesota. I really want to make sure that Minnesota builder gets exactly what he's looking for because they do build differently there. I've discovered through my experience. But anyway, this engineering, it looks pretty simple, but it is worth paying the engineer, if nothing else, so he can take on the liability. And if I'm the builder, that's what I'm going to want. So now let's look at, we're starting at the top. We're putting a load on the next thing we're looking at, which is the ceiling joists. Once again, we have a lot of details done here. Now, you can clearly see on the right side of this, we have the engineering. On the left side, we've got the details. Once again, this is where I start. And this legend is going to tell you how to interpret the plans, the little codes that he puts in. These are pretty much industry standard. I'll see, no matter who the engineer is, this is what I'm going to see. We've got joist designated differently than SW beam or strong back or glulam, APB, and that stands for Anthony Power Beam. That is a brand of glulam and wall framing. Generally, if I saw SW beam, I might interpret that as structural beam, or it could be a shear wall beam. And when I get into the plan, I'll figure that out. So we have header notes because on a single-story house, we're transferring the load just from a roof. But if this were a 2-story house or even a 3-story house, we'd be using 2x12 headers most likely, or maybe even engineered beams like more Anthony Power Beams cut down and used as headers because we're trying to transfer even a heavier load all the way down to the soil. So once again, the engineer has helped us a lot. And if I'm the builder on this, I've got a lot of security by reading this. So as long as we frame the house by these notes, I feel very safe that when the inspector shows up, he's going to pass this house with flying colors. And if not, we're going to have a conversation with the engineer. And I've even had it be where the engineer has to come on site and explain things to the structural inspector. So these are things that need to be considered, and this is one of many reasons why I'd recommend you have structural engineering performed for your house. But when we look at the house, not everything is in the details. The plans and the engineering are both graphical specifications for the expectation of how this house is to be built. I could write a notebook worth of instructions, starting with from the foundation and working all the way through completion on the home. But sometimes it's more efficient to draw the picture, and as we saw with the elevations and even the floor plan, the architect can very well graphically show something a lot quicker than writing it down. In this case, our engineer we have some standard notes and details, but now what we're going to see is like this is the garage. He's telling us specifically how he's going to frame this garage, and I can tell you why he's doing this particular thing, because these are some very long joists. Typically in our area we use yellow pine, number 2 yellow pine, 2x12s. If these were 2x12 ceiling joists, would only be able to go safely at 16-inch on center, about to 22 feet. Some, if you're going to have a loading of storage above, you might go 12 on center and 24. inch on and 24 feet long. And you can get 2x12s longer than that, but the cost is terrible. It's just they get very expensive at that length. In this case, the builder or the engineer said, we're going to go with 12-inch tall, 26-foot long TJIs. That's truss joists, or I-joists is what they might also be called. They are a type of engineered wood product, EWP. And they have headers, by the way, designated double 2x6 headers. Once again, this is a good engineering, and he's giving us good details. Sometimes engineers, because they all use a different approach, sometimes they give us a coding code, CODE system, where they don't really tell us their TJIs. They might put I-28s, and you got to go look up what I-28 is or something. So that's annoying. In this case, he's really done the builder a good service because he's literally telling you what's going to go where. Let's look at the front porch here. 2x6 by 8 foot long ceiling joist. Well, as an estimator, I'm going to look at this. I'm actually still going to measure them. And because I'm kind of incredulous, engineers are not estimators. So look what will happen if I give them 8-foot members. They're probably not going to have enough, because what this beam is going to go to the outside of this, in this case, this post you see, and then I'm going to run it all the way to the other side of my wall. You can see the way they've drawn these. They've drawn these as if they only have to go halfway on top of the top plate. Well, which is right and which is wrong? And I'm going to say they're both right. Code allows you to have, if I have a wall, code allows you to butt 2 joists right on top of that wall. And so if this were a 6-inch wall or 5.5-inch wall, I would expect 2.5 inch, 2 3/4 both sides, right? And that would pass code, but the framer's not going to frame it that way. Look what they did. He drew these as offset. And what I know as an estimator, having talking to hundreds and thousands of builders in my life, they're gonna offset them this way, right? And so what I do still, he says they're 8-footers, I'm going to give them 10s. But that's my prerogative, just like it's the engineer's prerogative to supersede the plants. Now, what I might do is pick up the phone and tell the builder, but you know what? A lot of builders don't want the details. They just want the lumber to show up and be enough. And so in my estimate, I'm going to put a note that says I gave you 10s instead of 8s. That's not an uncommon thing. So what we're doing here is like this one. This engineer kind of did 2 things. He said this beam is a 2-2-1-2 beam that is to be interpreted as a double or a 2-2x12 or 2-inch by 12-inch beam. Now, by the way, for the newbies in the crowd, a 2-inch by 12-inch beam is a non-starter. There's no such thing. That is telling us it's a 2x12, and it's the nominal dimension. A 2x12 is really 1.5 by 11.5, and once again, depending on the mill, your mileage may vary, at least as far as the width of the board is concerned. I've seen a 2x12 24 that comes out 11.25, and a 2x12 8 that comes out 11.75. So take that. But what this engineer has done is an excellent job of telling the builder the safe way to build this house. And considering we are in such a litigious society these days, people want to sue for the silliest things. In this case, if the builder builds according to this engineering, he should feel safe that if he does get sued, he may be named, but he's going to transfer that liability down to the engineer. And if he has an engineer's inspection, which is an engineer's inspection, I think is far better than a city inspection. Or even a code compliance inspection, which some do all 3, because it protects the builder. The more inspections the builder does, the safer the builder can feel when it comes to that type of thing. And if you're the consumer, if you're the person paying the bills, this is what I want you to remember. You don't want to end up in court, not ever. You don't even want to say the word lawsuit anytime during construction. It changes the atmosphere. What I would want you to remember, that everybody from your designer or architect to the engineer, to the builder, to the estimator in my case, it's it's our hope and our dream to get you in that house, that you enjoy that house, that you get the best house possible, because we know that you're paying the bills. And at the end of the day, there is no cheap way to build a house without building it cheap. So the biggest question to you is it worth it? While even in some areas of the country, you might be able to build without structural engineering. My question back to you is that a good idea? So after hearing whatever I've said, if you come to me as an estimator and you don't have structural engineering, I'm not going to shame you. It's a little late in the game for me to try to convince you to get engineering. What I am going to do is work with you. We're going to talk about the different areas of the home. I'm going to make sure that you're clear on knowing that I'm estimating this and I need to put something on this plan so that I can translate that to the estimate. And I'm going to get you to approve those the different elements that I'm going to include. First off, confirm that you allow me to make those judgment calls, and that those judgment calls are purely for estimating purposes and not for construction purposes. I'm going to make sure you know that. But as long as you know that, I'm okay giving you my best opinion. But at the end of the day, the best opinion you can get on code compliance, I think, is going to be your engineer. So I hope that has helped you understand the kind of the nature of engineering as a component of all of the construction documents that you really need. And if you're going to build today, it's not as easy as it might have been even 20 years ago. We have to consider things like windstorm, if you're in a hurricane-prone area such as Southeast Texas. If you're building in the mountain, you might have to think about seismic. Certainly if you're in California, that's an issue. You might have to worry a lot about, if you're building in LA, they're going to be very concerned about fire in arid areas of our country. So certainly before you get into this, you need the best experts on your team as you can. I hope I've done a good job of encouraging you just to pay the price, do it right. And I think if you put the right people on your team, you're going to have a great house. So Dan McJunkin with Houston Builders, thanks for watching. I hope this video has been helpful to you. I know it's long, but if you're going to build a house that's going to take you 18 months to build, it's worth spending a few minutes with somebody like me just receiving information. And I know that you're watching a lot of stuff on YouTube, maybe some other stuff that you find right here on HoustonBuilders.com, and I hope it helps you. If you need a lumber takeoff, I do hope you'll give me a call. 832-277-7203 is my number. You can find out more about my company, Residential Estimating, at residentialestimating.com. And of course, you'll see some samples of my work, and I think that'll help you make your decision on who you want to have do some estimating work for you. Thanks.